Hey guys, welcome back. We'll continue with Python crash course, and today we're going to focus more closely on lists. We learn how to loop through lists, how to deal with indentation errors when working with lists, and also we'll learn about tuples and how to style our code in Python properly. So let's get right into it. So in the previous video we already learned how to create a simple list and how we can work with individual elements in a list. However, that was quite inefficient because we had to select each element individually. And now we're going to learn about a much more efficient way we can actually loop through all the elements of our list. So let's take a look at an example. So inside of Sublime Text we can define a list of magicians. Let's say we have 3 different magicians here. And now instead of selecting them individually, you can do is we can use a for loop, and we can say that for each magician in our list called magicians, we can go ahead and we just print that out. And so we can always basically set our own variable name here after the for, and that will be assigned, magician in this case will be assigned to each element in our list. And then it's important that we indent the next line. So here we're then printing out the value of magician. And our for loop will go through each element of our list, starting with Alice, then on the next loop, David, and then finally Carolina here. So what's going to happen is we're going to print out the first value, which is Alice. Then we loop over again, print out the second value, David, and then in the third turn we print out Carolina. So let's actually run our code. We can see that's exactly the output we get here. So basically looping through the different elements. And we're really free to select any name here. So we could say, for example, instead of magician, we can say person, let's say. Then we of course also need to adjust the variable name here, but this will work just as well. We can simply define any name here to use it with. So let's do something a little bit more complicated. We can say we are using an f string here, and then of course, just as we did before, we can reference our variables. So here we want to reference, let's change that back to magician. We want to reference magician. We can call title on it for the right case. We can say to each magician that was a great trick. So let's run that, and then of course we print out those 3 sentences here, and we basically have a little bit more of a complex statement that we're making. Now let's add a little bit to it, so we can go and add another f string here. Let's say, for example, it can't wait to see the next trick. And again, we can add the magician's name here, use the title method. And then let's add a new line here. So as we do that, we basically execute 2 statements here for each value of the list. So for Alice, for example, we'll print out Alice, that was a great trick. I can't wait to see your next trick, Alice. And then we have a new line here, so we're going to have an empty line, and then we'll continue with David with the next value here. So this is basically what we get back here. So we print out each of the individual lines here. Now, just as we did this here, we can of course also put something after our loop. So let's say at the end of our show, we want to print out something like, thank you everyone, that was a great magic show. And now since we did not indent this last print statement here, it's outside of that loop. So it will not be printed out each time we iterate through the loop here, through our list, but it will be at the end of it. So that means if we run that again, we can see that we have those 3 lines being printed out inside our for loop with Alice, David, and Carolina. And then after the loop here at the end, we have that print statement here. And it's really important that we get the indentation right, because if, for instance, we indent this here, then this will print it out each time we go through the loop. So we need to really be careful that we avoid those kind of indentation errors that happen. The indentation really shows Python or the Python interpreter what should be executed in which scope of our program, so should it be part of our for loop or should it come after or before our loop. So let's say, for example, we go ahead and we print this statement here. Instead of indenting that, as we would typically want to do this, we actually outdent it here, so it's at the same level as the for loop. That means inside of our for loop, we only have that one print statement here. That's going to be executed for all three values. But after the third turn here, magician will actually be equal to Carolina. So here, when we have that print statement, it's actually just going to print out Carolina and not Alice and David. So let's take a look at that. If we run that, we can see for each of the magicians, we actually print out this line here. But now, since we did not indent this properly, we get back, I can't wait to see your next trick, Carolina, but it only refers to the last value here. So that's something we have to really be mindful of. We should really pay attention to that. And if we even try to outdent this first print statement here, we'll actually get an error because now we don't have anything inside of our for loop. Python or the Python interpreter always expects that the line after our for loop here is actually indented. So let's run that and we indeed get an error here. It tells us we have an indentation error. It expected an indented block here. So it expected this line to be indented after the for loop, which was not the case in this scenario. Of course, we can fix that by indenting it like this, and then it works properly again. We should also make sure that we don't indent unnecessarily. So for example, if we just comment this out real quick, and let's say we have a message here that says hello Python world, if you think back at our first program that we wrote, and then if we now have a print statement and we print out our message, that of course works properly. But if we try to indent this here without having to, like this, actually we'll get another indentation error, and this time it tells us that it found an unexpected indent, so that's not what we expect to happen. So we should really be careful when we work with indentation. Another common error that we may encounter is the following. When we actually have our print statement here and our for loop, we always need to make sure that we end our for loop with a colon here at the end. If we remove that, we'll get a syntax error. So Python always expects a colon at the end of our for statement, and if that's not there, that's invalid. So we need to have a colon at the end, and then we need to indent the next line. So let's take a quick look at some exercises. Here we have a couple exercises to work through. The first one is pizzas. So we should think of at least 3 kinds of different pizzas and then store those in a list. And then we should use a for loop to print the name of each pizza. So let's go ahead and let's create a new list. And we could write something in here. For example, pepperoni. So like this. And of course we can go ahead and say, let's call this pizzas, plural. And we can go ahead and we say for pizza in pizzas, just print out each value. So now we get those 3 values back here. So now we should modify our for loop to print a sentence using the name of the pizza instead of printing just the name of it. So for example, we should print out I like pepperoni pizza. Let's do that, and let's simply replace that print statement here. We're going to use an f string, and we can go ahead and say I like, then the name of the pizza. So that would be pizza, let's use title case here. And now we can see that this is printed out properly. Next, we should add a line at the end of the program, but outside of our for loop, that states how much we like pizza. So for example, I really love pizza. Let's do that. Now we need to make sure that we properly outdent this, so it's not inside of our for loop. And we can say, I really love pizza. And of course, we have to use quotation marks here, so that's a proper string, and then we can execute that and it runs properly, and it's just repeated once here because it's outside of our for loop. Let's take a look at the next exercise here. So we should think of at least 3 different animals that have a common characteristic. Store the names of those animals in a list and then use a for loop to print out the name of each animal. So let's do that. Let's remove all of that and we can create a new list called animals. And let's say, for example, we have a dog, we have a cat, and maybe we have some kind of bird. This, and then we should print out the name of each of those animals. So we can say for animal in animals, we need to make sure that we don't forget the colon here, and then we print out the animal. Then we get back those 3 values inside of our list. Next, modify your program to print a statement about each animal, such as the dog would make a great pet. And then add a line at the end of the program stating what these animals have in common. Alright, so we can go ahead and use an f string inside of print. So we can say a, and then we want to put in the name. Let's use the title method again. Would make a great pet, like this. You just run this real quick and it is going to print out those 3 ones. It actually removes the title because we don't need it. So this is printed out properly, and then at the end here we can have a print statement. We can say any of these animals would make a great pet. Alright, let's just print it out once because it comes after the for loop here. So next, let's cover actually some numerical list, meaning we can work with certain functions like the range function to actually use numbers inside of our list. So what we can do is, if we want to print out, let's say, the numbers from 1 through 4, we can go ahead and we say use a for loop again, for value in, and now instead of having a list in here, we can use the range function. So we say we want the range 1 through 5. We want to print out the value, and the important aspect here is that the second argument we pass to it, so the 5 in this case, is exclusive, so we'll have the values 1 all the way up to, but not including 5. So here we print out the values 1 through 4, and this is basically how we can use our range function. If instead we wanted to have the values from 1 through 5, we would basically take the next number here and say we want to have the range 1, 6, and that's going to print out the values 1 through 5 because the upper value is basically exclusive. And we can combine what we learned here about ranges with lists. So it's very easy to convert a range to a list. All we need to do is basically to pass list to it, like this. And this will basically turn our range here into a list. So let's say, for instance, we have numbers and that should be a list. So what we want to do is we want to have a list with the values of 1 up to and including 5. So now we can use range 1, 6, and all of that should be converted to a list. So we type that in here, and then let's just print that out to see if it works properly. So here we see we now have a list of the values 1 through 5 inclusive. Now range can actually take a third argument, and that allows us to specify basically the space between those numbers. So let's say, for example, we want to have all the even numbers between 2 and 10 inclusive. If we want to do that, we can define a new variable here, even numbers, and we can use our range function again from 2 all the way up to 11, because remember the current number here is exclusive. So if we want to have 2 to 10, we actually have to enter 11 here. And now, in order to not get every single value, but only basically the even numbers, we can say we don't want each individual value, but only every second value. So as a third argument, we pass 2 to it. So it's going to take every second value of our list here. And then we turn that into a list by adding the list argument in front of it. And here the list function basically takes the range operation like this. Now let's take a look at that. Let's just print out the even numbers. And now we see we have the values 2, 4, 6, 8, 10. Because we take a look at the range 2 to 11 exclusive, and we go in steps of 2. So that's why we get 2, 4, 6, 8, and 10 back. Let's say we want to do something a little bit more complicated, and we want to, for example, work with exponents and get a list of the values from 1 to 10, but not just the values themselves, but we want to square them basically. So let's do that. We can define an empty list squares, and then we can use our range function again to take a look at the values from 1 to 11 exclusive. So we're gonna go through all of them, and we go ahead and we define a new variable called square, and we take the value, so 1 to 10 here, and we square it, so those two asterisk symbols here, that allows us to take the exponent. So we're going to square 1, then 2, then 3, then 4, and so on and so forth. So once we square this, we can go ahead and we can add that to our squares list up here, and we learned about the append method, so we can simply select append square. Let's finally take a look at that. So outside of our for loop, let's just print out squares. This should be squares like this. Alright, let's take a look. So we basically get back the numbers 1 to 10 squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. So that's how we can use a for loop to accomplish that. We can see, however, that we can actually simplify our code a little bit. Here in this line, actually, what we do is we take the square of each value and then we append that. So instead of storing that in a variable, what we can do instead is we can take this expression here and we can simply directly add it to append. Like this. Now if we run that, we get the same output back as before. So that's one way of actually simplifying that. And one little aside here, if we want to work with large lists of numbers, for example, and we want to perform some statistical operation on it, there are some very helpful methods that Python provides. So let's just comment this out for a second. And let's say, for example, we have here a list of digits. So maybe that could be a list of digits, well, basically all the digits 0 through 9. And now if you want to find the minimum, so the smallest value here, what we can do is we can use that min method and pass digits to it. And let's just print that out to take a look at what we get back here. So if we do that, we can see the minimum value is 0. If instead we want to find out the largest value, what we can do is we can use the max method here. Let's run that again. And now we get back a 9, which is indeed the largest value. And if we were to change this, for example, to, let's say, 72, we run it again, we get 72 back. So it automatically finds the largest value in here. What's also very handy is to be able to create the sum of all of these values here. So that is the sum method. If we do that, we actually get back 45, which is the sum of all of these values. There's actually a little bit of a more advanced concept that we can use when we want to perform some operations on lists, for instance, and we want to write it in a very succinct way. And it's called list comprehension. So a list comprehension basically allows us to generate the same list in just one line of code. So what we can do is following. Instead of typing all of this, let's just comment the upper part out here. Instead, we can do the following. We can say we define, again, squares, which is going to be our list. And now we're going to use the bracket notation here, so we know what we get back as a list actually. And now we can say we want to take a value, we want to square it. And now this is the expression we want to be performed, which is the same as up here. But now we say we want to have that happen as part of the expression that comes next. So we add a for statement for the value in, and now we take the range again, 1 through 11. So basically we took those 3 lines here and we facilitated and we added that into one line. So here we take the value. So basically we have the for loop here. So we loop through each element in the range of 1 to 10. that's stored in value, and then we square the value. And this entire expression here is then stored back into our list. We repeat that for each value in our range. So basically what we get back is the exact same result as before. If we run that, we get again 1, 4, 9, and so on and so forth, so the numbers of 1 through 10 being squared. So list comprehension can be really useful. It can look a little bit complicated at the beginning, it's a little bit more advanced, but it can save a lot of space basically, and can be a little bit more expressive to work with. So let's take a look at some of the exercises here. The first one is to count to 20, so we should use a for loop to print the numbers from 1 to 20 inclusive. Let's do that. We can use our for loop and we can say for, let's say, number. We can again use any value here, and then we use our range operation, and we want to use the range from 1 to 21. Remember, the value here is exclusive, so we actually get back 1 to 20. And then we can simply say we want to print out a number. So now we get the values from 1 all the way up to 20. Next exercise here is to make a list of the numbers from 1 to 1 million and then use a for loop to print the numbers. Okay, so we first want to create a list of numbers from 1 to 1 million. So let's take our numbers here. We want to have a list. So what we can do is we can take our range operation. We want to have values from 1 to 1 million. So actually we want to have the value 1 million and 1 here. And then this range here, we want to turn that into a list like this. So now we basically have our list of the values from 1 to 1 million. We can just briefly print this out. And here's really where you can see the power of what we're learning here of the loops. It takes a little while to go through the entire list, but now we have created that list from 1 to 1 million, so it's a pretty huge list. And now what we should do is we should use a for loop to print the numbers. Right, so now we can say the following. For each number in numbers, we want to print that particular number. And that may take a little while to run. We can see here we are now in the 400s, and now we are done. So if we had a much larger list, it could take a very long time to run. In such a case, we can always press Ctrl+C to basically interrupt the execution, which can be helpful, so we don't have to wait for such a long time. So next, we're building on top of that. We want to sum a million, so make a list of the numbers from 1 to 1 million, which we already did, and then use min and max to make sure that the list actually starts at 1 and ends at 1 million. Also use the sum function to see how quickly Python can add a million numbers. Alright, so we have our numbers list up here, and let's first of all go ahead and use the min function to find the minimum number, and of course we want to print that out, so let's wrap all of that in print statement. So we get back 1, which is the smallest number here, and now we can pretty much do the same here for the maximum number, so we just change that to max. That is indeed 1 million. Now finally we should create the sum, so this would be sum numbers, and again we can print that out. And we can see that's basically almost instantaneously, so we can perform some operations on pretty large numbers very, very quickly, so that Python is really powerful when it comes to that. So next is odd numbers. We should use the third argument to our range function to make a list of the odd numbers from 1 to 20, and we should use a for loop to print each number. So to do that, we can say for number, and we're taking a look at the range 1 through 20. And of course we want to go in steps of 2, so that should start with 1, then 3, and 5, and so on and so forth. So let's go ahead and print that number. Now we get the numbers 1 all the way up to 19, which should be all the odd numbers. Next, we should make a list of the multiples of 3 from 3 to 30. Use a for loop to print the numbers in your list. So let's first create the list. So let's just call it numbers. And again, we have our range operations here. We are starting with 30, with 3. We're going all the way up to 30. So passing in 31, just one number larger than that. And then we want to go in steps of 3. To turn that into a list, we pass this to list, and that's now inside of numbers. And we can first of all briefly print numbers just to check that we actually get back the expected results. So here 3, 6, 9 all the way up to 30. That's looking good. And then we should go ahead and we should use a for loop to print the numbers. So we can say, and let's change it up. Let's say not numbers, but maybe just n. For n in numbers, you can really use any name in here, pretty much. And then we can go and print n. So now we get back all the individual values printed in a separate line. So next we can continue with cubes. So a cube is basically a number raised to the third power. And we already took a look at squares, so now we're taking a look at cubes. And we should make a list of the first 10 cubes. So that is a cube of each integer from 1 through 10. So we should create the list first and then use a for loop to print out the value of each cube. So let's do that. Let's have a cube here. And what we want to basically do is we can create an empty list for now. And then we can say for, say, value in range 1 through 11. What we want to do is we want to append to our list. And we can use the third power here. So cube append and then value asterisk asterisk 3. So let's afterwards print out cube. And now we get back the list of cubes. So those are basically the numbers 1 through 10 cubed. And now we still want to print out those values. So we can say for n in cube, for example, print out n. And those individual values of our list are then printed out. So we can accomplish that, but there's of course a quicker way to do that. So we can use hook comprehension, a list comprehension, to generate a list of the first 10 cubes. So we basically want to accomplish what took us 3 lines here in a single line. So to do that, let's simply do cube equals again. We want to have a list back. And what we want to do is we want to take our value basically, and of course we don't have to call it value, we can call it n, for example. Cube it for n in our range from 1 to 11. All right, and then we still want to loop through it and then print out each value. So let's take a look, and we still get back the same result. So that's a quicker way to do that using list comprehension. Now, when we work with our list, sometimes we don't want to work with the entire list, but only with part of a list. And in Python, part of a list is basically called a slice. So we have the option to actually slice a list. That means we can basically take our list and we can just use part of it. And let's take a look at that. We can go ahead and, for example, create a list here of different players. And we simply add the names of those players into our list. And then we can take that and basically slice it up to just take a look at some of those values. So we defined our list of players here with those 5 different values. Then of course we can go ahead and we can print out our list of players, which gives us back those 5 values. But if we don't want to take a look at the entire list, but only at part of it, we can create a slice. And the way it works is we basically take the bracket notation here, which of course allows us to use an index to basically get those individual values. So for example, player 0 would of course be the first element. But now we don't want to get just a single element, but we basically want to get the first 3 elements. So we basically take a look at players from index 0 to, but not including index 3. So if we run that here, we get Charles, Martina, and Michael back. So those 3 values at index 0, 1 and 2 and 3 is exclusive here. So that's how we can use a slice to get a part of the list back. We can of course also change the boundaries here. Let's say we don't want to start at the first value but at the second value, but then we want to get the next 3 values. So here we go from index 1 all the way up, but not including index 4. So we get back Martina, Michael and Florence. We can, if we want to start from the beginning of the list, we can actually omit the initial value here. So we could of course type this 0 through 4. So these are the first 4 values, but instead we can just use a shorthand notation and simply remove the 0 here, and then we automatically start from the beginning of the list. In a similar way, we can, for example, start at a certain value. Let's say, for example, here we want to start from the second index here, Michael, and then we want to go all the way to the end of the list. We can run this and then we get that back. So here also we can just write the number, the index, colon, and then delete that empty, and that will be from that particular index to the end of the list. And of course we can also apply what we learned last time about accessing values in a list. We can of course start from the end by using minus. So we could say -3, for example, run that, and then we start from Michael here. So this would be -1, -2, -3. So those are the last 3 values here. And then using the colon here, now we go all the way to the end. All right, so we now learned about slices. We can also loop through slices. So if we take our list of players here, we can then go ahead and say for our player in players. And now we don't want to take the entire list, but let's say, for example, we just want to create a slice here. So we start from the beginning up to, but not including index 3, so 0, 1, 2. So we should get Charles, Martina and Michael back. And now we can go ahead and say we want to print those values. Let's actually use title case here. Let's run that. So we get those 3 values back here. That's basically how we can use a slice to only get back part of the list. This is how we can work with slices, so they can be really useful just to get a subset of our list. Another very useful case is actually copying a list. So if we have a list and we want to create a copy and then make some modification maybe on the copy but not on the original list, in order to accomplish that, we actually would also use slices. Let's take a look at that. Let's actually create a list my foods, and let's say, for example, we have pizza in here, we have falafel, but also carrot cake. And then let's say we have another list called friend foods, and let's say, for example, our friend likes the same kind of food as we do. Instead of typing all of this out again or copying it over, we can simply copy our list. To do that, we would take the name of the list, and if we left it like this here, what we would basically do is we would reference my foods. So then friend foods and my foods would basically both point to the same list. So that means if we were to add a value to, for example, my foods, it would also be added to friend foods, which we don't really want to happen. So in order to avoid that, what we can do is we can use a slice notation, and we simply add a colon here, and that means we basically take the entire foods list up here. And since we didn't add any index in here, just the colons, we know that we reference the entire list, and that basically copies it over and stores it in friend foods. And now we can go ahead and say my favorite foods are, and then we of course print my foods. And we can go ahead and say we create a new line here, and let's say my friends' favorite foods are, and we simply print out our friends' foods. And at the moment, both values are exactly the same because we didn't really make any changes to either one of them, so we get the same values back. But let's now say we actually make some changes to those. So let's say we take my food, so our list up here, the initial one, and we append another type of food, cannoli for example. And then for our friends, they actually like something else, they like ice cream. Alright, so let's save it and run it again, and now we can see that we actually get two separate lists back. So my favorite foods are my foods, and then my friend's favorite foods are, and we get that list back, and the last value is actually different for both. And that may be subtle, but if we go ahead and we remove this here, so that we simply assign the list itself without copying it, without using that slice notation, what happens now is, as you can see, we now have basically the exact same values, because now instead of actually having a copy created of our list, we now point, so my foods and friend foods both point to this particular list. So that means when we go ahead and we append a value to either my foods or friend foods, since they both point to the same list, we basically append that to the same list, so we get the exact same output back. So to avoid that, to actually copy the list, we need to use that slice notation here, the colon, and then if we run that, we actually get a different list back. So that's subtle, but it's really important to understand, because this can be a very useful scenario to use slices and to work through this. So we don't have to worry about the details of that yet. We'll dive into that a little bit later in more detail, but for now it's just important to understand that this is a good way of using slices, how we can actually copy values over from one list to another one. So let's take a look at some exercises. The first exercise is here to use one of our programs that we wrote in this chapter and add several lines to the end of the program that does the following. We want to print the message the first three items in the lists are, and then we use a slice to print the first three items from the program's list. So let's say, for example, we had our list of animals before. So here we had a dog, we had our cat, we had a bird, and let's say, for example, we have a mouse, for instance. We can go ahead and we can print out animals, which will give us back the entire list. But if we want to just get the first three elements, we can say we want to just use the values from 0, so index 0 up to index 3 exclusive. So that gives us back dog, cat, bird, the first three values. And of course we can simplify that, removing the 0 like this. And now if we run it, we still get the same output back. So next we should print the message the three items from the middle of the list are, and use a slice to print three items from the middle of the list. And so in order for us to actually have a middle here, what we can do is we can add another value here, and then we can go ahead and we can loop through our list. So for each animal in our animals list, let's go ahead and let's actually print that out. So actually let's do the print statement outside of the loop, so we can say three items from the middle of the list are this. And then we can loop through that and basically print out each animal. But of course we don't want to have the entire animals list, but we want to start, let's maybe take those three middle ones. So we go from index 1 all the way up to, but excluding index 4. So 0, 1, 2, 3, 4. And then let's print that out. So we get back cat, bird, mouse, which is exactly what we see here. So next we should print the message the last three items in the list are, and use a slice to print the last 3 items in the list. So we can say the last 3 items of the list are. Alright, and now we want to go all the way from basically index 2 all the way to the end, so we can simply remove the end value here, and then we get back bird, mouse, horse, which are exactly the 3 last values in our list. Alright, so that was the first exercise. The next one is my pizzas, your pizzas. Start with your program from exercise 4 and make a copy of the list of pizzas and call it friends pizzas. Then do the following: add a new pizza. Alright, let's just get started and let's write down our pizzas here. So we had a list of different pizzas. So we have pepperoni in here. Let's take cheese like this. Alright, so then let's call it my friend's pizza, and now we want to copy that. So again, we use a slice notation like this to copy those values over without actually referencing the same pizza list. So now we add a new pizza to the original list and add a different pizza to the friend's pizza. Let's see, change that to friend pizza like this. Right, so I'm just gonna add some kind of pizza here, and then we take the friend's pizza and we add a different value to it, and then prove that you have 2 separate lists. Print the message my favorite pizzas are, and then use a for loop to print the first list. Print the message my friend's favorite pizzas are, and then use a for loop to print the favorite lists, favorite pizzas for our friend. So let's do that. Let's go ahead and let's start with a print statement. My favorite pizzas are. And then we can go ahead and we say for, let's say P in pizza, we can go ahead and we say we print out the pizza like this. And that gives us back a value here. And then we can go ahead and print out, let's add a new line here, so it's a little bit more separated. We can say my friend's favorite pizzas are. And now we loop through friend pizza and we print that out. Alright, so we get back my favorite pizzas are pepperoni, Rita, and so on and so forth. We see the last value here is actually different for our own list and for our friends list. So that shows us that we actually copied this over correctly using slices. And so we have 2 separate lists and we can modify them independently. So the next exercise, more loops. All versions of fruits in the section have avoided using for loops when printing to save space. Choose a version of puts.pi and write 2 for loops to print each list of fruits. So basically that's what we already did here. We used the for loop to accomplish this. So we printed out those values. So finally, let's take a look at tuples. Tuples are a different data structure, different from lists that we have used so far. And they're actually very, very similar to lists in a lot of ways. So lists are really great for storing collections of items that can change throughout the life of our program. If we don't want those values to change, then we would use tuples, because tuples themselves cannot be changed. They're immutable. That means the values assigned to them cannot be changed during the lifetime of the program. And tuples are created in a very easy way. And just to give a little bit of context, one really useful way to use tuples, for example, would be if you have some kind of values that would not change. So for instance, if we have some dimensions, for example, of a game that we are playing, we don't want it to change, then we can define that as a tuple. And we can define a tuple just by using parentheses instead of a bracket notation. That's basically the only difference. And we have to have commas in there, of course, that separate the various values that we are working with. So let's take a look at that and let's define our first tuple. we can take dimensions as a tuple, and if we wanted to create a list, of course we would use the bracket notation and write it like this. Now we want to use a tuple instead, so all we have to change really here is to use parentheses instead of the bracket notation. And now, just as with lists, we can go ahead and we can reference individual values. Here again we would use the bracket notation, so let's print out those different values, dimensions, or the value of dimensions at index 0, which is 200, and then the value at index 1, which is 50, so we get those two values back. So we defined those different tuples and we printed that out. But now if we try to do the following, let's say for example we want to take our dimensions tuple up here and we want to change the value at index 0 to, let's say, 250. And now let's run that, and now we can see we get an error back and we get a type error here. So a tuple object does not support item assignment. That shows us that we actually are not allowed to make a change to that value because it's a tuple. If we make a very slight change and change that tuple to a list using the bracket notation like this, then we don't get an error here because we can of course change the values of our lists, but tuples prevent us from doing that. So that's why we get that error message. So tuples can be really useful if we want to work with some values that should not be changed. So that's a really handy option to choose. And just as a side note, when we work with tuples, we technically need always a comma in there. So if for whatever reason we want to define a tuple that has just a single value, for example 200, then we can't write it like this. Just remove this real quick. We will get an error back. So we get back type error int object is not subscriptable because we technically always need a comma in here. Otherwise it will not be defined as a value. Let me remove this because of course there's only one value in here. So now we can see we don't get an error and we actually get the value of dimensions at index 0 back. If we were to remove that comma, then we would get the type error here. So it's very rare that we would define a tuple with a single value, but if we do, then we need to add that comma in here, just in addition to our value. The most frequent case when that would happen is actually when the tuples are generated automatically. We can also, just as with lists, loop through the different values of our tuple. So if we, for example, change our tuple back here to have the values 250 included, we can of course go ahead and say, for example, for dimension in dimensions, we want to print the value here of dimension, and that returns those two values. Important to mention, while we cannot modify a tuple itself and cannot change the values, it's still possible to overwrite our tuple. So what we could do is, if we have our dimensions here of 250, we can go ahead at a later stage and we can change or basically reassign dimensions to a different tuple. So for example 400 and 100. And if we take a look at that, and let's just print out here modified dimensions. Now we can go ahead and print out for dimension in dimensions, print out the dimension again. So here initially we have a tuple with the values 250, and then we reassign that using the same name here to 400 and 100. And now if we run that, we can see that we actually changed those, or we didn't change the values, but we basically overwrote the tuple with the same name. So we cannot change the values here, but of course we could define a new tuple by the same name and then assign different values to that. That's something just to keep in mind. So let's have a quick exercise on tuples here. It's actually a single one. So here we have a buffet style restaurant that offers only 5 basic foods. So we should think of 5 sample foods and store them in a tuple. So let's do that. We can have here foods, and of course to create a tuple we use the parentheses. And now let's say we have pizza in here, we have pasta, maybe rice, potato, and for example red. So that's the tuple we just defined. Then we should use a for loop to print each food the restaurant offers. And then we should try to modify one of the items and make sure that Python rejects the change. Right, so we can go ahead and we say for food in foods, print food, this. So we print out those values, that works properly. And now let's try to actually modify value here. So let's say the first food should not be pizza, for example water or something else. And then we get back an error message here because of course the tuple object does not support item assignment. And then finally the restaurant changes its menu, replace two of the items with different foods, add a line that rewrites the tuple, and then use a for loop to print each of the items on the revised menu. So to do that we actually would need to override our foods here. So we can go ahead and define a new tuple. So I'm just going to add some drinks to it, if it's our menu, so water and Coke for example. And then we're going to have rice still in there, potato, and our bread, like this. And then we should print that out. So we say for food in foods, let's go ahead and print out food. And then of course we can see we now have water and Coke in here, so we overrode the tuple and thereby basically quote unquote changed those two values, but we actually didn't reassign it, but we redefined the tuple, and that's the only thing we can do. Now finally let's take a look at styling our code. We have been writing a little bit of longer programs, and it's important to understand how we can style our code properly. And to do that, we want to basically follow some guidelines. And the goal typically is to write our programs in a way that it's easy to understand. So the easiness of understanding our code, that's typically the most important aspect. Not necessarily writing, but making it easier to write the code, but to understand and to read our code. Because of course typically we will read a lot more code than we actually write, even with our own programs. If we wrote them a while ago and then we have to read through them again, that is really important. And so therefore there are different kind of style guides or Python enhancement proposals, PEP, that are being used, and most likely the most popular one of those is PEP8, which is fairly common and is used most often. It can be quite lengthy, but it defines basically the standard Python style guides that should be used. There are different aspects that are being covered by that. One important one, for instance, is indentation. So PEP8 recommends that we use 4 spaces per indentation level. Technically speaking, we could either indent it by spaces or by tabs, but PEP8 recommends 4 spaces. That being said, of course, it would be quite bothersome if we always needed to indent it by typing tab or actually space 4 times, and therefore we can basically define in our text editor that we want to use a tab. When we press tab, we actually have a certain number of spaces that are being used here. So that's how we can basically do that in the background. And then there are also some specifics about the line length. So historically the line length was 79 characters because it's less than 80 characters, so 79 characters, because that was the longest length that could actually technically be displayed. And nowadays it differs a little bit, so some people prefer to work with a 99 character limit, but PEP8 actually recommends that we limit that to those 79 characters, and that can be really useful, especially if later on we work with separate text files, we have them both open on the same screen. Then it can be really handy to have that available. So also another point, and of course there's a lot more to PEP8 than that, but we should add some blank lines, for example, at the end of our code, and there should be a certain number of blank lines in between, for example, functions that we're going to learn about later, so that our code is very easy to read and has a good overview. And of course, there's a lot more to PEP 8 that is listed here, but those are some of the fundamental parts. As an exercise, we can take a look at the original PEP 8 style guide that is defined here. And a lot of different text editors actually support that out of the box. So for example, if we use, there are different libraries we can add to our text editor that will then automatically apply PEP 8 to it. Here we can see the specifics. So PEP 8 was actually authored by Guido von Rossum, who is the creator of Python. So that has been created in 2001, so quite a while ago. And here we can see the contents. So for example, regarding indentation, tabs or spaces, and so on and so forth. There's quite a long list of specifics. But again, we initially just need to focus on the most important aspects. So then next we should choose 3 of the programs that we have written in this chapter and modify each one to comply with PEP 8. Specifically, we should focus on using 4 spaces for each indentation level. And ideally, we should also set our text editor to insert 4 spaces every time we press tab. And we should use less than 80 characters in each line and set our editor to show that a vertical guideline at the 80th character mark. We should not use blank line excessively in our program files. So let's go through each of those requirements in turn. So let's first specify 4 spaces for each indentation level that should be inserted once we press tab. So if we go over to Sublime Text, we can actually go over to Settings, Preferences, Settings. And here we can specify tab size. So here we want to change that from 2 to 4. And we want to translate tabs to spaces. That's true. So let's leave it like that. And now if you take a look, we now press tab. We actually have here 4 separate spaces. So that worked properly. Next, we should use less than 80 characters on each line. And so we should display a vertical guideline at the 80th character position. To do that, we can go up to View, and then there's the option Ruler, and here we can set that to 80. And so after 80 characters, we actually have that line here. So we always know basically when we are above the line. So finally, we should not use blank lines excessively in our program files. So we haven't really been doing that, but we could remove some of those blank lines, maybe here also on top. And so we can adjust that. And of course, we could then adjust that here so it's compliant with PEP 8. We learned how to work efficiently with lists in Python, how to use a for loop, and also the slice and range operation. We covered indentation in Python and also learned about tuples and how to style our code properly. In the next episode, we're going to cover if statements and how to deal with conditionals. So see you guys in the next video.